Two ships leave from the same point at the same time. The larger ship is traveling at 25 kilometers per hour. The angle between the ship's courses is 25 degrees. After 2 hours, the ships are 28 kilometers apart. How fast is the smaller ship traveling? Here we will first calculate the distance traveled by the larger ship in 2 hours. The speed is equal to distance divided by time, and so the distance is equal to the speed times the time. We can then draw a diagram and solve for the appropriate side. The distance traveled by the smaller ship. Note that the distance traveled by the larger ship represents one side. The distances between the ships after 2 hours represents a second side. And the angle between the ships' courses represents the angle opposite the second side. Be aware that here we have the potential for the ambiguous case when using the sine law. From the time and the distance traveled, we can then calculate the speed of the smaller ship. First of all, let's figure out the distance traveled by the larger ship. The distance equals the speed times time. Its speed was 25 kilometers per hour. Traveling for 2 hours gives a total distance of 50 kilometers. We can then start drawing the diagram. This larger ship has traveled 50 kilometers. That's going to be one of the sides. We know that the angle between the ships was 25 degrees. We also know that the distance between the two ships after the 2 hours was 28 kilometers. Note here, though, that there are two possible triangles. We have two possible ways that we can have that second side being 28 kilometers. We will then use the sine law initially to calculate, first of all, sine B and then angle B. Note that the initial case, we're going to be calculating the acute angle B, and then we have to get the obtuse angle B by subtracting it from 180 degrees. Here we get sine B equals 0.7547, which is angle B equals 49.0 degrees. And again, we also take this 49.0 degrees and subtract it from 180 degrees. This gives another possibility for angle B of 131.0 degrees. First of all, we'll look at the angle B of 49.0 degrees. We can first figure out angle C. Angle C is equal to 180 minus 25 degrees, which was angle A, minus 49 degrees, which was angle B. We then get angle C being 106.0 degrees. We can then use the cosine law to figure out side C. Side C, or C squared, is equal to 28 squared plus 50 squared minus 2 times 28 times 50 times cosine of angle C, 106 degrees. Taking the square root then of both sides, we end up with side C equals 63.7 kilometers. We then do the exact same thing, this time for angle B being 131.0 degrees. This corresponds to angle C being 24.0 degrees. And side C, after plugging it into the cosine law using 24 degrees for angle C, gives side C of 26.9 kilometers. These measures for side C will correspond to the distance traveled by the smaller ship. We can then use the formula relating speed, distance, and time. The speed is equal to the distance divided by the time. We can simply divide each of these distances by 2 hours. This gives two results. One of 31.8 kilometers per hour. That was from doing 63.7 divided by 2. And the other result, 13.5 kilometers per hour. That was from taking 26.9 kilometers divided by 2 hours.